Stephen Hinton here from the Swedish Sustainable Economy Foundation. You'll find us at tssef.se. I want to talk about supply chains and how they can be part of a circular, sustainable economy. Now, let's get started. We like to talk about production as being one big box. If you like, the economy is working within this box, and it's made up of firms, often in a capitalist way. That's to say that they are owned by someone who provides employment, and employees earn money to buy goods and services from these companies or from other places, and pay taxes, etc. What's often forgotten, of course, is the material base of the economy, and that's very important. It doesn't really have the same sort of connection to money. Let me show you what I mean. Um, the economy needs the biomaterial, which it gets from the ecosystem, and from the lithosphere, it takes minerals, and these are, for example, metals, but also things like sand, etc. The lithosphere is the layer under the living layer, with the rocks containing all the ores and all the stuff we use in the modern economy. Now, to get it into this production system, we need to extract it. Of course, we could say that the extraction puts it into some kind of a mineral stock, and from the ecosystem, it's harvested. Again, it comes into a stock. We see it as a stock and flow concept here. Now, what happens then is, of course, that this is used in the production system, and then it needs to go back if it's a circular economy. I mean, eventually, if it's not replaced, then we will use up all of the minerals in the lithosphere, and there's a risk that we'll degrade the ecosystem to a point where we can't harvest as much. So we can see that we have a replenishment of the mineral stock, and that we have, in terms of ecosystem, biological material will go back into the ecosystem as a recipient, or there'll be work done, or work done to restore the ecosystem. So that's the kind of basic, I think it's very simple, kind of schema that we want to talk about. Let's look then at what goes on inside that box. So let's look at what goes on inside that box. Getting things to the customer, there are 4 steps. Making the materials ready to go into production, and then products are distributed and then used by the customers. There are 2 support services. One, of course, is that all of this needs energy, and the other is recycling. Now, the main flow of materials goes to the customer and then to recycling. However, if we look a little deeper, of course, energy supply needs materials. For example, if you're burning wood or oil. And of course, the energy supply is needed in order to extract materials. Indeed, coal mines all require their own little mini power station to run them. Energy supply goes to all of the 6 steps, 6 functions that we're talking about. And then, of course, recycling happens from production. Any waste goes into recycling. That goes back into the various stages of production as well. And I mean, you can even second-hand and repair, for example, that goes directly into being used again. Now, there's one aspect of this that's really important, and that is that production does not just produce products, but it produces infrastructure. It produces tools and other kind of things that are needed by the other steps. So we represent it with a red line. For example, you need to produce wind turbines. So that produces energy, or dams, I suppose you could say. You need to distribute, so you need to make cars. And indeed, you need to produce recycling equipment, so everything's recycled. Now that gives us not many flows to look at. Maybe there are around 30 different key flows in order to be able to describe supply chains in a way that is relevant to material use. Now, it's not always clear what's going on with supply chains when you buy a product. I want to give an example here. Buy a car, and I've got an old car, and a big one, and it does 9 liters to go 10 kilometers. Now, where does that petrol come from? Well, it has to be transported to the gas station. That might require maybe 10%, I don't know. Let's say roughly. And in that case, it puts up my consumption per, or the effect of my purchase of that car and purchase of the petrol. It puts it up, maybe up to 1.1. Now, the tanker, of course, needs to get its petrol from somewhere. But the other part of it is the tanker needs to be manufactured, and so do all the cars. Now, what we know is that the energy or the oil required to manufacture a car is roughly the same as the car uses in its lifetime. So what we'll do there is we'll add that double on to the figure. Okay, we got that far, but what about where the oil comes from? It needs to be refined. And here we need to add another few percentage on top of that, not just of the petrol produced, but of all the petrol needed and the oil needed in the whole production. So let's add a bit on that. And then finally, it takes oil to get oil out of the ground. It used to be like 1 barrel of oil can get out 100, but we're getting on close to 1 barrel of oil is needed to get out 8. So let's add that figure to it and there you see it's 2.2 liters for every kilometer you drive. 10 kilometers. So that just shows you that when you purchase something, the supply chain and the supply chain effects on the environment are often hidden. Now let's carry on a bit. Fortunately for us, Swedish Statistics have what they call SNI, which is how they collect statistics on different kinds of industries. And they have an industry nomenclature which starts at A and ends at U, roughly. Now, good for us is that the extracting part of it is A and B. That's to say, the biological is A and the minerals, metals is B. In terms of production, it's C, and production of houses, or buildings, and roads, etc. It's F. D is energy supply. In terms of distribution, we have motor vehicles and things like that, but we also have I2U services, and here we can pull out H, which is transport. I think we need to look at that one separately for various reasons. So we'll have H as so distribution will be 2. It'll be transport. It'll be G and I to U, and then H. Use is households, which is T. And then we have recycling. Now, recycling isn't broken down as much as we'd like it to be because it's got water supply in it. Otherwise, the rest is real waste treatment. Now, that gives us in Sweden some interesting statistics. Now, this one is for energy use and types of industry per category. We've chosen here A, B, C, and then H, and the rest we put into a one category. And then the types of energy, we've got electricity, which is blue, district heating, which is green, dark blue, other fuels. Natural gas, town gas is orange, crude oil is grey, coal and coke, kind of orangey, and sort of a medium blue is biofuel. Now let's look at how that pans out. And here we can see the majority of crude oil petroleum products used in transport. And that, interestingly enough, that's for fuel, but interestingly enough, over 63% of what's used is the private car. Cars use more than lorries do. If we go to manufacturing, we see that there's a lot of biofuel and electricity, which comes from nuclear or hydropower. But manufacturing uses coal and coke more than crude oil and natural gas. But actually, it's a smaller proportion than used in transport. And finally, in service and housing, here there's some crude oil used for heating and coal and coke. Now, what this tells us is that if we want to defossilize Sweden, we have three very simple strategies. The first one is to insulate houses so they don't need all of that fuel, and then we can reduce, and you can see that you don't need to reduce that much, maybe 10-20%, and then you can heat with the other sources. The other thing is you need to replace private car transport. That's that would get 63%, or replace private car transport with internal combustion engines. Maybe electrifying, maybe using public transport. There's a lot of interesting things there. And then the other would be to make products live longer. If you made products live longer, you wouldn't have to manufacture them. Of course, you should prepare them, but you wouldn't have to manufacture them, and that's where a lot of the energy. The same could be said of actually of housing, as we'll see in a minute. Let's take this information and look at it another way. Let's go wider. Now here, let's look at the big percentages. We've got here waste, employees, GDP, greenhouse gases, and energy use. Major waste comes from mining. So again, and construction. So again, if we were to keep what we have instead of make more, then we could reduce that. Say we doubled the length, then we would halve that kind of impact. Let's go to the next one, which is greenhouse gases. We know again this manufacturing uses a lot greenhouse gases. Remember, these greenhouse gases come not just from fossil fuel, but they come from biofuel as well. So you've got manufacturing and construction, and in service, most of that is transport. When it comes to employees, you'll find that most are employed in service. The hit, if you like, of reducing manufacturing and reducing construction, although in fact, in terms of employees, the construction employees would be on dealing with existing buildings, and manufacturing employees would probably be working more with repair. So there wouldn't be a really big hit on employment necessarily. When it comes to energy use, we can see again that it's manufacturing and G2U service. And we've also got D there, which is energy heat, including sewage. Of course, that would show up there. And then finally, GDP. This is interesting because most GDP actually comes from service sector. What this means is that in terms of money, the industries that you want to change, that's the same manufacturing, and that would affect mining and construction and the others, probably doesn't have the money to do it, to do the transition. The money is actually in the services which have most employees, and probably, if you exclude transport, the least of greenhouse gases. But the strategy is the same: insulate houses, replace private car transport, and make products live longer. When you say it like this, it doesn't sound too hard. Now, let's have a look at this again. The firm is the basic unit of all production. Let's start with the production process itself. What does it need? Well, it needs inputs. These are, as we showed earlier, energy, biological inputs, mineral inputs. It needs employees. It produces products and services. And to do that, it needs infrastructure. Now, it puts out emissions, apart from products and services, and it produces waste. Now, if you think about it, if you had a firm that didn't have any need for any infrastructure, you could actually produce the products, sell them, and then you'd be able to take that money, pay the employees, and pay the people who gave you the inputs. However, firms need the infrastructure because without the buildings and the tools and the machinery, they won't be able to exist. So, or run their operations. So therefore, they need that investment up front. So the investment in infrastructure is key here, and that's something we need to look at. So what we could do is we could actually have a bit of a mathematical model. We could say that I would be the infrastructure, J the employees, W the waste, E the emissions. We could start to quantify the whole thing, and then we could look at the bigger version of the supply chain with all these different parts. And as you can see, you could actually, for each product that comes up, you could have a total unusable waste. You can add up the whole thing, number of jobs produced, and even the total value of that you could work out, and you could work out the total emissions. You can also see the amount of mineral stock that comes back, and also the biological mineral stock that comes back in natural capital. So you could do a lot of mathematics on this. Now, if a supply chain is going to be circular and sustainable, it has to fulfill certain requirements, and these are driven by the infrastructure. So for example, in terms of operation, it should be able to run on renewable energy. In terms of inputs, it should be able to use recycled inputs or nature-based inputs. In terms of products, they should be able to last a long time. And in terms of waste, it should produce recyclable waste. Now, in theory, you could ask this question of each company in the supply chain, and they would be asked to say the percentage of their infrastructure that performs in this way, and then the investment cost to make it sustainable. In summary, there are 6 different types of actors that make up supply chains, and they're related to the SNI statistics, which are fairly common in other places. We seldom hear total supply chain impact. We as consumers and citizens don't really get the whole picture. At least for Sweden, 3 strategies would give major gains. We reduce heat loss from buildings, we get rid of ICE, private cars, and we increase product lifetime. Now, for investment, infrastructure performance is essential. If it was included in each company's reporting, it could be calculated for whole supply chains. And that's really what I wanted to say. Stay in touch for more videos and more thoughts about accounting, supply chains, economics, etc.